Our modern world is built from materials that will outlive us for 1,000 years. Plastics that choke our oceans and concrete that will never decay. We have engineered a world of permanence, a world of waste. But what if we could grow our future instead? What if our buildings, our clothes and our products were made from a living material that at the end of its life simply returned to the earth? This is the story of mycelium, and it's the beginning of the biological revolution in manufacturing. Welcome to Eco Innovatech. Today we're not looking at a machine or a mega project. We are exploring a living organism that is being hailed as the supermaterial of the 21st century. It's the root network of fungi, a sprawling, intelligent and incredibly strong natural polymer. We will show you how scientists and engineers are learning to program this nature's internet to grow everything from biodegradable packaging that replaces styrofoam to leather jackets that are grown, not farmed, and even architectural bricks that are stronger than concrete. This is the innovation that could allow us to build a truly circular world. When you see a mushroom, you are only seeing the tip of the iceberg. The mushroom is merely the fruiting body of a much larger, more complex organism. Hidden beneath the forest floor lies the true powerhouse, the mycelium. It is a vast, interconnected network of thread-like fibers called hyphae. This network is nature's nutrient highway, its recycling plant, and its communication grid. It can span for miles, breaking down organic matter and transporting water and nutrients throughout the ecosystem. For millennia, we have overlooked this hidden kingdom, but scientists have now realized that mycelium isn't just a part of nature. It is one of nature's most advanced technologies. The hyphae fibers are made of chitin, the same polymer found in the shells of insects and crustaceans. This structure makes mycelium incredibly strong, lightweight and naturally flame retardant, and its growth is programmable. By controlling its food source, temperature and environment, we can guide its growth into almost any shape imaginable. We don't have to manufacture it, we just have to tell it what to become. In our modern world, convenience often comes with a hidden cost. Consider the humble styrofoam cup, the protective packaging, cradling a new appliance, or the takeout container from a favorite restaurant. This material, known scientifically as expanded polystyrene, has become an invisible yet ever-present part of our daily lives. But its convenience is fleeting, while its environmental legacy is anything but. The first great success story of mycelium technology begins by confronting this legacy head-on, tackling one of the world's most persistent and insidious pollutants. Every year, our global economy churns out millions of tons of this petroleum-based material. It's a marvel of chemical engineering, lightweight, insulating, and cheap to produce. But its strengths in our supply chains are its greatest weaknesses in our ecosystems. Derived almost entirely from fossil fuels, its production is an energy-intensive process, contributing to carbon emissions. Yet its end of life is where the true environmental tragedy unfolds. Despite what we might hope, almost none of it is ever recycled. The infrastructure is complex, the process is economically unviable, and the material itself is often contaminated with food waste, making it a one-way ticket to the landfill. There, it doesn't biodegrade. Instead, it embarks on a centuries-long process of disintegration. It fractures into smaller and smaller pieces, becoming brittle under the sun's UV rays, breaking down into insidious microplastics. These tiny fragments infiltrate every corner of our planet, polluting our waterways, choking marine life, and contaminating the very soil we depend on. A material designed for a single brief use will remain in the environment for at least 500 years, a permanent monument to a temporary need. This is the problem mycelium was born to solve. The solution, pioneered by visionary companies like Ecovative Design, is as simple as it is brilliant. It doesn't rely on complex chemistry or intensive energy inputs. Instead, it harnesses the quiet, relentless power of nature's master recycler. The process begins not with petroleum, but with the abundant leftovers from our own agricultural systems. And they take low-value organic waste, materials like corn husks, hemp hurd, or wood chips that might otherwise be burned or left to rot, and see it not as trash but as a valuable resource. This feedstock is first cleaned and pasteurized to remove any competing microbes, ensuring the mycelium has a clean slate to work its magic. This prepared agricultural waste is then carefully placed into a mold. These molds are reusable and can be designed to create virtually any shape imaginable, from protective end caps for electronics to custom-fit inserts for furniture. This is where the true ingenuity lies. Instead of forcing a synthetic material into a shape, the shape is simply a container, a guide for a biological process that will unfold. Once the mold is filled, it's time to introduce the master architect, the mycelium. Specific strains of fungi, often from the Ganoderma lucidum or reishi family, are selected for their rapid growth and strong binding properties. A small amount of these living fungal spores, often suspended in a liquid culture, is introduced into the mold. This is the moment of inoculation, the beginning of a silent biological manufacturing process. The stage is set for nature to take over, transforming humble farm waste into a high-performance material. The inoculated molds are then moved into a dark, controlled environment with specific humidity and temperature levels. Here, away from the light, the mycelium network awakens. The spores germinate, sending out millions of tiny thread-like filaments called hyphae. This is the vegetative body of the fungus, and it begins to grow at an astonishing rate, feeding on the nutrients locked within the agricultural waste. The hyphae act as a living, self-assembling glue, secreting powerful enzymes that break down the complex carbohydrates in the corn husks and wood chips. As it feeds, the network expands, branching out in every direction, weaving itself through and around every particle of the substrate. It's a process of digestion and construction happening simultaneously. The mycelium is binding the loose material together, creating a dense, interconnected composite matrix. In just 5 to 7 days, without any additional energy or human intervention, the mycelium network grows to fill the mold completely. It has consumed its food source and, in doing so, has formed a solid, lightweight, and perfectly shaped object. The once loose collection of farm scraps has been transformed into a single cohesive piece of custom packaging, grown to precise specifications. Once the part has reached its final form, it undergoes one last crucial step. A final heat treatment in an oven effectively dehydrates the material and stops the biological growth, rendering the fungus inert. This ensures the final product is stable, safe, and won't continue to grow or fruit. The result is a packaging material that is not just an alternative to styrofoam, but a significant upgrade. It is just as shock absorbent and protective, but its environmental credentials are in a different league entirely. A life cycle assessment, which analyzes the environmental impact of a product from creation to disposal, reveals a stark contrast. Styrofoam production is a linear extractive process that emits significant carbon dioxide. Mycelium packaging, on the other hand, is part of a circular regenerative system. It's grown using a fraction of the energy, and because it's made from plants and fungi that sequestered carbon during their life, the final material is often carbon negative. It literally stores more carbon than was emitted during its production, and its greatest feature is revealed at the end of its life. Instead of persisting for centuries, you can simply break it up and return it to the earth. Placed in your garden or home compost bin, it safely decomposes in about 45 days. It doesn't just disappear, it becomes a valuable soil amendment, releasing nutrients and enriching the very ground it came from. It completes the biological cycle, turning waste back into a resource. This isn't a futuristic concept or a boutique experiment. It's a proven, scalable reality. Major global companies constantly searching for ways to reduce their environmental footprint and meet consumer demand for sustainability are leading the charge. Giants like IKEA and Dell are already using mycelium to replace their plastic and styrofoam packaging for a range of products. They recognize that this technology isn't just an environmental win, it's a logistical one. The cost is competitive with traditional petroleum-based plastics, especially as the scale of production grows and the price of oil fluctuates. For these corporations, mycelium packaging offers a powerful story of innovation and responsibility. It eliminates plastic waste, reduces their carbon footprint, and provides their customers with a simple, guilt-free way to dispose of packaging. The adoption by these industry leaders sends a clear signal. Biological manufacturing is not only viable, but is becoming a competitive advantage. It proves that we can uncouple economic growth from environmental degradation, creating products that are both high performance and planet positive. This successful disruption of the packaging industry is just the beginning, a powerful proof of concept for the quiet revolution growing all around us. For centuries, our relationship with fashion has been defined by a difficult compromise. On one hand, we have animal leather, a material steeped in tradition but fraught with environmental consequence. The raising of cattle for leather and meat is a leading driver of deforestation and a massive consumer of fresh water. It takes an estimated 15,000 litres of water to produce just 1 kilogram of leather. The tanning process itself, which transforms raw hide into a durable material, is even more problematic. Tanneries often release a toxic cocktail of chemicals, including chromium, arsenic, and cyanide, into local waterways, poisoning ecosystems and endangering the health of workers and nearby communities. On the other hand, the rise of so-called vegan leathers presents its own insidious problem. While they spare animals, most are simply plastics like polyurethane or PVC derived directly from fossil fuels. Every time these synthetic garments are worn or washed, they shed microscopic plastic fibers that pollute our oceans, infiltrate our food chain, and ultimately end up inside us. The fashion industry, in its quest for materials, has found itself caught between two forms of pollution. But what if there was a third path? A way to create a luxurious, durable material, not from an animal or a barrel of oil, but by partnering with nature itself. Mycelium offers this third, far more sustainable path. The solution begins by harnessing the fundamental engine of the fungal kingdom. By growing mycelium in carefully controlled vertical farms, companies can cultivate a material that is truly revolutionary. Inside these facilities, the conditions are perfect. The mycelium is fed a diet of agricultural byproducts like sawdust and corn husks, turning waste into value. Temperature, humidity, and carbon dioxide levels are all precisely managed, encouraging the thread-like hyphae to grow and weave themselves together into a dense, interlocking mat. This process is a form of natural three-dimensional weaving. In a matter of weeks, not years, these tiny threads form vast, flexible sheets of a material that looks, feels, and performs with the same quality as the finest animal leather. Unlike animal hides, which come with natural imperfections, scars, and irregular shapes that lead to significant waste during cutting, mycelium can be grown into uniform sheets of specific dimensions. This radical efficiency means that nearly 100% of the material grown can be used, representing a monumental leap in sourcing, resourcefulness. But the true genius of mycelium lies in its programmability. This isn't just one material, it's a platform for a potentially infinite variety of materials. By subtly altering the growth conditions or the food source, scientists can direct the mycelium to create different properties. They can grow this unleather to specific thicknesses, from a supple, delicate material perfect for gloves to a tough, rigid hide suitable for boots and bags. The texture can be customized during the finishing process, allowing for everything from a smooth, patent finish to a deep, pebbled grain, all without the harsh chemicals of traditional tanning. The environmental savings are staggering. Mycelium leather requires a tiny fraction of the land, water, and energy needed for cattle farming. And because it's grown in a closed loop system, there is no agricultural runoff. The entire process is designed to be regenerative. At the end of its life, a product made from pure mycelium leather isn't destined for a landfill for 1,000 years like its plastic counterparts. It can be composted, returning its nutrients to the soil and completing a perfect circular life cycle. This is not a distant futuristic dream, it's happening right now. The world of high fashion, often seen as exclusive and traditional, is embracing this biological revolution. Visionary luxury brands like Hermès and Stella McCartney have already partnered with pioneering startups like MycoWorks and Bolt Threads to create stunning high-end fashion products from mycelium leather. These collaborations are more than just marketing experiments. They are a powerful statement of intent. They prove that sustainability and luxury are not mutually exclusive. Consumers can have the beauty, durability, and status of a high-quality leather product without the ethical and environmental baggage. This marks the beginning of a new era in materials, one where our clothes are not just assembled in a factory, but are quite literally grown from the ground up. It's a future where our desire for beauty and self-expression can be aligned with the health of our planet, creating a system that is both ethical and fully biodegradable. Fashion is being reimagined not as a source of waste, but as a partner in regeneration. This is where the true scale of the mycelium revolution becomes clear. While transforming packaging and fashion are significant steps, the greatest environmental impact of humanity comes from our built environment. The cities we live in, the offices we work in, the very infrastructure that supports our modern lives are built upon a foundation of extraction and emission. Concrete production alone is responsible for an estimated 8% of global CO2 emissions. That's more than the entire aviation industry combined. We quarry mountains for gravel, dredge riverbeds for sand, and burn immense amounts of fossil fuels to create the materials of modern construction. This linear extractive model is fundamentally unsustainable. But what if we could shift our paradigm? What if we could move from an industrial process of extraction and assembly to a biological process of cultivation and growth? What if we could grow our buildings instead of pouring them? This is the frontier of mycelium architecture. Researchers and architects are now developing methods to create myco-bricks. The process begins not in a quarry but on a farm. It takes agricultural byproducts like sawdust, hemp hurd, or cornstalks, materials often considered waste, and uses them as a nutrient-rich food source or substrate. This substrate is then inoculated with mycelium. Over the next few days, in the dark and with controlled humidity, the fungal network gets to work. Its microscopic hyphae extend and branch out, weaving through the substrate, digesting it and binding it together into a dense, solid matrix. Once the mycelium has fully colonized the substrate, within a brick-shaped mold, the growth is halted with a gentle dehydration process. The result is a building block that is incredibly strong, astonishingly lightweight, and provides excellent insulation. The properties of these microcomposites are remarkable. They are naturally fire retardant thanks to the chitin in the mycelium's cell walls. They offer superb acoustic dampening, creating quieter interior spaces. And crucially, they are exceptional insulators. A wall made from myco-bricks can have an insulation R value 3 times higher than that of traditional fiberglass, meaning buildings require significantly less energy to heat and cool. This isn't just about reducing the carbon footprint of construction, it's about creating buildings that are more efficient and cheaper to run for their entire lifespan. And at the end of their use, these bricks aren't destined for a landfill. They can be broken up and returned to the earth, where they biodegrade completely, enriching the soil. This isn't merely a laboratory theory, it's been proven in the real world. In 2014, a visionary team of architects and designers at MoMA PS1 in New York built a towering organic structure called Hi-Fi, constructed entirely from myco-bricks grown from cornstalks. The installation was a powerful demonstration. It proved the structural viability of the concept, showing that these grown materials could bear loads and create breathtaking architectural forms. Hi-Fi was more than just a sculpture. It was a beacon illuminating a potential future for construction where our buildings are part of a circular, regenerative ecosystem. It captured the public imagination and catalyzed a new wave of research and development in the field. The innovation doesn't stop there. Perhaps the most futuristic and revolutionary concept being explored is self-healing materials. Researchers are experimenting with leaving the mycelium in a dormant but living state within the bricks. If a crack were to form, exposure to air and a little moisture could reactivate the fungus, prompting it to grow and literally heal the damage, extending the building's lifespan indefinitely. This is the ultimate promise of bioarchitecture, not just to build with nature, but to build structures that behave like nature, resilient, adaptive, and alive. Scientists are now experimenting with living, self-healing structures. By keeping the mycelium within the bricks alive but dormant, it's possible that when a crack forms and water enters, the mycelium could wake up and regrow, healing the structure from the inside out. It is the ultimate expression of biomimicry, a building that behaves not like a static object, but like a living organism. The path to a mycelium-based world is not without its challenges. Scaling up production to compete with the global plastics and concrete industries is a massive undertaking. Ensuring the long-term durability of these materials in harsh weather conditions is a major engineering hurdle, and we must develop a global supply chain for the agricultural waste that serves as the mycelium's food source. But the potential is limitless. We are standing at the very beginning of a new industrial revolution, the age of biomanufacturing. We are moving from an extractive model of industry to a generative one. For the first time, our manufacturing processes will not just be less bad for the environment, they will be actively good for it. They will be based on carbon negative materials that heal the soil at the end of their life. Mycelium is the flagship innovation of this new era. It is teaching us that the most powerful factory on earth is not a building full of machines, but the hidden intelligent network that has been engineering our planet for over 1 billion years. From the styrofoam in our packaging to the concrete in our cities, we have built a world that is designed to last forever, and in doing so, we have created a global waste crisis. The mycelium revolution offers a profound new vision, a vision of a world built from materials that are grown, not manufactured. A world where our products are part of a natural cycle of growth and decay. A world where human industry finally learns to work in true partnership with nature's oldest and most brilliant technology. The future isn't synthetic, the future is alive. If we could grow almost anything from mycelium, what is the first plastic or concrete product you would want to replace? Let us know in the comments. For more on the innovations that are building our sustainable future, subscribe to Eco Innova Tech. Thanks for watching. The future isn't synthetic, the future is alive.